This is the sixth lesson in Chapter 1. This lesson is all about solving proportional relationships, and this is a big one for us, so a lot's going to go on. Pay close attention. First, we're going to start with vocab. First word here is proportion, and a proportion is an equation stating that two ratios are equal. So, two important pieces of this definition, and let me see if I can find my highlighter here. Yes. All right, so the first important word here is equation. And we all know what an equation is. An equation has an equal sign in it. It tells us that two things are equal. And this particular equation is telling us that two ratios are equal. Okay, so what that means is we are going to have one ratio, like 1 to 2, and we're going to say that it is equivalent or equal to the ratio 2 to 4. And that is a proportion. Now, we talked about proportions earlier on. We talked about proportional relationships. The focus of this lesson is going to be solving a proportion when an element is missing. So let's say ours looks something like this. X to 12 equals 6 to 8. And we could do some math to figure out what that missing element is. Okay, so let's talk about our notes for this lesson. First note, if two ratios form a proportion, then their cross products will be equal. So a lot of 7th graders like to talk about cross multiplication or cross products. Here's where they come in handy. Cross products are useful in solving proportion problems, and that's pretty much the only time we end up using cross products in math. So important ratio words, words that indicate when we should be writing a proportion are terms like for each and for every. Okay, whenever we talk about for every 2 cups of flour, we have 1 cup of sugar, or for each child, there are 6 stickers. Those are words telling us this is probably a ratio problem, and we should have cross products kind of set up in our mind already. Okay, so let's talk about how we can use cross products to see if we have a proportion. So the first type of question, are these ratios proportional? And we did see a question like this back in Chapter 1, Lesson 0. The way to use cross products to answer this question is to multiply the denominator times the opposite numerator for both ratios and see if we get the same product. So 24 times 10 is 240. 16 times 15 is 240. So the answer is yes, these two ratios are proportional. They do form a proportion. Okay, so that's the very, very basic way to use cross products. We can also use cross products to solve for a missing variable. So in this case, we're trying to solve for the a. When I do cross products this way, I like to always start with the product that has the variable in it. So I start with 25 times a, and I write that as 25a. And then I bring down my equal sign, and then I multiply the other diagonal, 40 times 15, and 40 times 15 is 600. So what happens is we take our proportion, we write the cross products as an equation. And now we have to solve our equation. So now we have to think back to 6th grade solving equations, and we would write our train tracks there, and then we would divide both sides by 25 because our job is to isolate the variable. Okay? And the 25s cancel each other out. We are left with 1a. Bring down your equal sign. And 25 goes into 600 24 times. You can check my math if you'd like. So the missing term in that proportion is 24. Okay, a equals 24. That's it. That's as easy as it is. Let's see a word problem. Here's your example number 3. Word problem. Alex gains 5 pounds for every, look at that, for every 2 inches he grows. If Alex grows 7 inches, how much weight will he gain? Well, we talked about these, some of those words telling us that there's a ratio problem or that we might want to try and set up a proportion. Here's that example, for every. So when we see that word, it kind of triggers our thought to set up a proportion. And we first want to write a ratio, and that ratio in this case is 5 pounds to 2 inches. 5 pounds to 2 inches. Now we don't have money or time here, so it really doesn't matter which one you put on the top or on the bottom, as long as when you write your proportion, you put the same units in the top on both ratios and the same units in the bottom for both ratios. Okay, so 5 pounds to 2 inches, Alex grows 7 inches. So that means that 7 has to come down here in line with the 2. And we are solving for how much weight he will gain. And I'm just going to put an X there for that. So our ratio is 5 to 2. Our other ratio is X to 7. We know that they are proportional, so we have an equal sign in between. So we just have to use cross products to solve for X. So I always start with the product with the variable in it. 2 times X is 2X. Bring down your equal sign. 5 times 7 is 35. And we can draw our train tracks. Divide both sides by 2 to get the variable isolated. And we get X equals 35 divided by 2 does not work out evenly. So let's just show our math here. 2 goes into 3 once. 1 times 2 is 2. Subtracting, get a 1. And bring down the 5. 2 goes into 15 7 times. And 2 times 7 is 14. We subtract and we get a 1. You have a choice at this point if you want to do fractions or decimals, because nothing in the problem tells us which one to do. I'm going to do fractions here. The remainder becomes our numerator. Our denominator stays the same. So our final answer is 17 1/2 pounds. Don't forget to put your units into your problem because this is a word problem. Okay? So, toughest part here is setting up your proportion. Didn't matter which one we had on top, pounds or inches, as long as we were consistent on both sides. And then we can do our cross products and solve. Write down any questions that you have, update your flashcards, and we'll go over this again tomorrow in class.